I am Vedanshi, your buddy. Today we are going to start a new topic, N-gram model, a statistical language model. Let's begin with the introduction to N-gram model. An N-gram is simply a group of N things that comes one after the other, like words or letter in a sentence. For example, if N is 2, we have two words together, which is called bigram. If N is 3, we have three words together, which is called trigram. In text, we use n-grams to look at how words or letter fit together. This helps us to predict what word or letter might come next in a sentence. Imagine you have a box of crayons and you are like to draw a picture with them. Let's say you want to draw a picture using 3 crayons at a time. Now, let's think of each crayon as a word in a sentence. If you choose 3 crayons to draw a picture, that's like a 3-gram. You are picking 3 crayons to make something special. If you want to guess what the next crayon is going to be, you look at the 3 crayons you already picked and try to guess what might next come. Just like in a sentence, you can guess what word might come next based on the word before it. Now, let's talk about why are n-grams important. Modeling word sequences. N-gram helps us to understand which word often appears together in a sentence. For example, in a phrase, I love ice cream, the word I and love usually go together, and so do ice and cream. N-gram helps to predict how likely certain words are come next based on what we have already seen. Simplifying language complexity. Language can be tricky, but n-gram makes it easier by breaking down long sentences into smaller, simpler chunks of words. We need to understand the full meaning of everything, just how words usually connect to each other. Predicting next word. Have you ever used your phone and it gets the next word while you are typing? The next word comes through an action of n-grams. It looks at the word you have typed so far and tries to guess what word might come next, like in search engines or while texting. So n-gram helps to figure out how words fit together and make predictions about the next time. Let's go to the examples of n-gram model. Unigram or 1-gram. This is just one word at a time. Example, if you say I am learning, the unigram are just the individual words I am learning. It is counting how many times each word shows up without worrying about the order of the words. This is useful when you want to know which words are common. Bigram or 2-gram. This is when we look at the pair of words next to each other. For example, in a sentence, I am learning NLP. The bigrams are I am learning NLP. Bigrams are good when we want to understand how two words work together. For example, they help us to guess the next word or fix spelling mistakes by knowing what words usually go through. Trigram or 3-gram. This is a group of 3 words that appear together. Example, in a sentence, I am learning NLP. The trigrams are I am learning NLP. Trigram helps to understand a bit more of sentence. They are better than bigrams or unigrams because they know more words together, so they can predict what come next more accurately. Higher order n-grams, 4 grams, 5 grams, etc. These are the group of 4, 5 or more words together. For example, in a sentence, I am learning NLP with models, the foregrounds are I am learning NLP, am learning NLP with, learning NLP with models. As the number of words in a group gets bigger, the model can guess more correctly with the context. But it can also get harder because these are fewer examples of longer words grouped in a data. Now come to the next topic, n-gram probability. N-gram probability. Imagine you are trying to guess the next word in a sentence. The probability tells how likely a word is to come next based on the words before it. For example, if a sentence is I am learning, you might guess the next word NLP because the word I am learning often leads to NLP. The formula is probability of word on the n time upon the probability of n minus 1 to 1, which means what is the chances of word wn will come next on the basis of the words before it. Chain rule of probability. Sometimes it's hard to calculate whole probability at once, so we break it into smaller, easier parts. The chain rule helps us to do this. It says that we calculate the chance of each word happening by looking at each step one by one. Instead of trying to calculate the probability of all words together, we look at the probability of the next word based on the word before it. Then move to the next word and so on. So the formula becomes probability of word n with the probability of word n minus 1 producted with probability of word n minus 1 with probability of word n minus 2 till probability of word second to the probability of word 1. Now we will be covering smoothing techniques. What is Laplace smoothing? Imagine you are guessing the next word in a sentence, but the word combination like I love unicorn have never appeared or have never seen before in your data. Without Laplace smoothing, the probability of these word combination will be 0 because they have never happened. But we don't want to give up on them completely. Laplace smoothing is like adding a little bit, usually 1, to every word pair, even if you have never seen it before. This ensures that every word combination has a chances of happening, even if it's new to the model. Why is Laplace smoothing used? Problem of zero counts. In real life, there are many words or many words combination that just haven't seen yet. And without smoothing, these combination would have probability 0. Solution can be by adding 1 to the each word combination, we make sure that even new, unseen combinations still have tiny chance of happening. This makes the model more comfortable and accurate when predicting the new word. Formula will be probability of word n to the probability of word n minus 1 is equals to count of word n minus 1 and word n plus 1 divided by count of word n minus 1 plus v, where v is the number of unique words in the entire data. Now, how smoothing works? Numerator, top of the formula. This is where we add 1 to the count of each word pair. This ensures that even if we have never seen the word before, it doesn't get a 0 probability. Denominator. This is where we add v to make sure all the probabilities are added to 1. We also get the total count of the first word in a pair, which shows how often the word appears. So if I has appeared 5 times in a total, the denominator will become 5 plus V. For example, for a bigram I am, the probability of am with respect to I is equals to 3 plus 1 by 5 plus V. This gives us a nice probability for am after I, even though we have seen it 3 times. For a bigram am learning, probability of learning with respect to m is 0 plus 1 upon count of m plus v. Even though we have not seen m learning before, Laplace models still give it a tiny probability by adding 1 to the count and using the total number of m and v. Applications of n-gram model. Speech recognition. N-gram models helps to convert speech to text. They look at the words you have said and predicted the next word to make the transcript more accurate. So if you have something like this, I want to go, the model predicts the next word might be something like home, based on the common patterns. Machine translation. When we translate one language into another, like English to Spanish, N-gram model helps the system to understand how words fit together in a new language. They predict the most likely translation by looking at the order and context of the word. Text generation and prediction. In things like predictive text, N-gram predicts the word that might type next based on the word you have already typed. For example, if you type I love, the system might guess that you will type pizza because I love pizza is a common phrase. Spelling correction and autocomplete. N-gram can also suggest the spelling correction or help finish the sentence when you are typing. If you have make a typo or leave a word unfinished, the model will guess the rest of the word or phrase based on the common words pair or pattern. Now, with our last topic, limitations of n-gram models. Data sparsity. Imagine you have a huge book of words and you have trying to find all the words pairs, triplets, or even longer sequences. As n gets bigger, the number of possible word combinations increases a lot. This means many of the data combinations won't even appear in a book, leaving a lot of empty spaces where the model can't learn anything. This makes it harder to predict those unseen combinations. Limited context. N-gram looks at the small window of words, but they don't see the entire sentence. So if you have sentence like the cat jumps over a big fence, the trigram model might only see the word the cat jumped and cat jumped over, but it won't connect the as a subject with fence object which is far apart. This means the model might miss important connection that spread out in a sentence. Memory and computational complexity. To store all possible n-grams for huge amount of text take up a lot of space and memory. For example, if you have a huge book with a many possible combination of words, the computer needs a lot of power to keep track of all these combinations. This can be slow and need a lot of resources, especially when n is large. Lack of deep semantic understanding. N-gram models are just about counting and predicting word combination. They don't really understand what the word means. For example, the model might know that happy and joyful are often appear similar in a similar context, but it doesn't truly understand both words meaning something positive. This makes Ngram model not very good for tasks that need deeper thinking, like figuring out the sentence is happy or sad, or sorting documents based on their topic. I hope you find this video useful. If you find it useful, please like it and subscribe to the channel. Thank you.